Imagine building a business where if the air conditioning breaks, the vacuum pressure inside the building gets so incredibly strong that your customers literally can't push the front doors open.
Right. They're just physically trapped.
Yeah, trapped. Or, imagine a scenario where someone leaves a random plastic button in their pocket, it washes down the drain, and suddenly you get hit with a massive environmental fine from the county.
It sounds wild, but it happens.
It really does. Welcome to the Deep Dive, everyone. Today we're taking you on a mission to unpack the massive hidden complexities behind what looks like a painfully simple commercial renovation.
Extremely simple from the outside. Yeah.
Exactly. Our subject today is a very specific project. It's 610 N Combi Road in Lakeland, Florida, right over in Polk County.
A great case study for this.
Definitely. So we are looking at a 3,878 square foot vacant shell. And the goal is to transform it into a commercial vended laundromat.
Right.
And we're going to dive into why, assuming this is just some plug-and-play retail space, is a really, really dangerous game.
Because, well, when you walk past a laundromat, the illusion of simplicity is just profound.
Oh, for sure. You just see washing machines.
Yeah, washing machines, some folding tables, maybe a nice neon sign in the window. But the reality is a commercial laundromat is not a retail store.
No.
Not at all. It is actually a highly technical, high-output industrial utility plant. It's just disguised as a neighborhood shop.
Disguise is the perfect word for it.
Right. So if an investor approaches a project like Combi Road and treats it like a standard vanilla box renovation.
Meaning like just throwing up some drywall and painting.
Exactly. A little paint, maybe updating the overhead lights. If they do that, they're walking blindly into a total financial disaster.
I mean, I want to stop right there and look at the actual dollars because the preliminary estimates we found in the sources for this vacant shell absolutely blew my mind.
They are definitely eye-opening.
To say the least. The total project cost ranges from a low of about $727,000 all the way up to over $1.8 million.
Yeah, that's a massive spread.
It is. But the sources say the most realistic benchmark for a project of this scale in Florida, based on the 2025 and 2026 industry numbers, is right in the middle.
Which is around 1.2 million, right?
Yes, about 1.2 million. And I have to challenge this. I just have to.
Go for it.
Because I know people who build custom luxury homes from the ground up for less than $1 million.
Sure.
How does a single open room that just washes and dries socks cost $1.2 million? I mean, is the general contractor just slapping some kind of commercial premium on this?
It looks completely absurd on paper. I totally get it. But you have to realize what you are actually building.
Okay, lay it out for me.
Well, if a standard retail remodel like opening a clothing boutique is like setting up a home kitchen, building this laundromat is like engineering a commercial bottling plant.
Oh, wow. A bottling plant.
Yeah. A standard commercial remodel in Florida typically runs in the low 200s per square foot. This project sits at roughly $309 per square foot.
That is a huge jump.
It is. But that extra premium isn't just arbitrary profit. You are doing a complete retool of the building's infrastructure.
Right.
And because of the extreme technical coordination that's required, this estimate includes heavy general contractor overhead and profit, usually around 25%.
Wait, 25%? Why is the coordination so intense that it justifies a 25% premium?
Because you are stuffing an industrial-grade mechanical system into a very tight neighborhood-sized footprint.
Okay.
For example, the plumber needs to trench the concrete floor to lay massive drain lines at the exact same time the electrician needs to run conduit.
Sounds chaotic.
And at the same time, the HVAC team needs to hang massive exhaust ducts from the ceiling. If the sequence is off by even a single day, the trades are literally tripping over each other.
And then the whole project just stalls out.
Exactly. So you are paying a premium for a general contractor who can direct that symphony without the building tearing itself apart.
That makes sense.
Plus, there's a highly necessary 10% pre-design contingency baked into that $1.2 million.
Because you always find surprises, right?
Always. In renovations like this, you will inevitably find expensive surprises hiding behind the drywall.
Okay, so if it takes that much money just to orchestrate the trades and prepare for surprises, where are the actual material dollars going?
You have to look behind the walls for that.
Right, behind the walls and under the concrete floor at the MEP. So mechanical, electrical, and plumbing.
The big three.
Yeah, this is the monster lurking in the budget. Looking at the estimates, plumbing is the absolute heavyweight here. The mid-range estimate is nearly $160,000 just for plumbing alone.
Yeah, because a standard retail space might have a 2-inch sewer line and a standard 1-inch water supply.
Which is fine for a bathroom and a sink.
Right. But that kind of volume wouldn't even wake up a laundromat. For the Combi Road project, the design requires upgrading to a 4-inch main sewer line and at least a 2-inch potable water supply.
That's a lot of water.
It is, but the sheer volume of water coming in isn't actually the real engineering marvel.
No.
No, the true expense comes from dealing with the water going out. It's a phenomenon called simultaneous discharge.
Simultaneous discharge. Okay,
Yeah.
I've seen standard residential washing machines drain, and it's just a steady, manageable flow.
Sure, at home. But this layout calls for 22 commercial washers.
22. Okay.
Now picture a busy Saturday morning at this facility. You have dozens of these heavy-duty machines running back to back.
People doing their weekend laundry.
Exactly. And by pure statistical chance, let's say 15 of them hit the extraction and drain cycle at the exact same millisecond.
Oh, no.
They suddenly dump hundreds of gallons of soapy water all at once. If you hook those up to standard PVC pipes...
The water just hits a bottleneck.
Right, it backs up instantly and floods the entire store. So to handle simultaneous discharge, the washers have to drain into massive, specialized concrete standpipes or engineered drain troughs.
Wait, drain troughs. So they aren't even using traditional closed pipes for the initial drain.
Frequently, no. They use an open trough system that's trenched directly into the floor behind the machines.
That sounds intense.
It is. The Florida Building Code dictates these troughs must be sized to handle 75% of the machines running and draining simultaneously without overflowing.
Wow. 75% at once.
Yeah. And the labor required to saw cut the existing concrete slab, excavate the dirt, pour a perfectly pitched concrete trough, and seal it all up. It's incredibly labor-intensive.
You are essentially building an underground river system inside a retail shell.
That's a perfect way to describe it.
Okay, so you have this underground river managing hundreds of gallons of water. But to actually force all that water out of heavy, soaky, wet towels in the first place, you need immense physical force.
You do.
And standard wall outlets obviously can't generate that kind of torque, which explains the electrical budget. The mid-range estimate for electrical is sitting at nearly 90 grand.
Yep. You are upgrading the entire building's electrical service panel to handle anywhere from 400 to 1,200 amps.
Just for context, a large modern home usually peaks at what, 200 amps?
Yeah. Exactly, 200. And on top of that, it must be a 3-phase service panel.
Why 3-phase specifically? I hear that term thrown around in commercial real estate all the time.
Think of single-phase power, which is what you have in your house, like pedaling a bicycle with only one leg.
Okay, sounds exhausting.
Right. There is a moment in the pedal stroke where you aren't applying power, which creates a slight pulsation.
I'm tracking.
Well, 3-phase power is like having 3 legs pedaling, evenly spaced out. It provides a constant, overlapping, totally uninterrupted stream of electricity.
Oh, I see. So there's no gap in power.
Exactly. Industrial extractor motors absolutely require that constant stream. It generates the massive, sustained torque needed to spin 80 pounds of soaking wet laundry at high speeds.
Without stalling the motor.
Precisely. And furthermore, the Florida Building Code requires that the 22 proposed washers have entirely independent circuits.
That's a lot of wiring.
Okay.
And it's not just the heavy-duty motors drawing that power, right? Looking at the source breakdown, modern laundromats are basically tech hubs now.
Oh, absolutely. The Combi Road layout relies on highly sophisticated, computerized payment systems.
So no more lugging around a bag of quarters.
Nope. Customers are using Bluetooth, smartphone apps, and tap-to-pay cards. Those networked systems alone represent an equipment cost between $40,000 and $80,000.
That is a massive investment.
And because they are highly sensitive computer boards sitting literally inches away from massive high-voltage industrial motors, they need specialized electrical grounding.
And probably heavy surge protection, too.
Oh, mandatory. One rogue power surge in a poorly grounded building could instantly fry the brains of your entire fleet of machines.
Just shutting down your business in a second.
Exactly.
Man, okay, so you have the massive water volume, and you have the immense electricity spinning the drums.
Mm-hmm.
But to actually dry the clothes, you need intense heat and airflow.
Which brings us to the mechanical, HVAC, and gas systems.
Right. This portion comes in at a mid-range of about $119,000.
Yep.
The sources show the gas demand is massive to feed 16 to 18 stack dryer units, which gives you 36 individual drying pockets.
That's a lot of heat.
They need large 8 to 12-inch exhaust ducts to push all that hot, moist air out. And this brings up what I found to be the most fascinating and frankly terrifying part of the mechanical design.
Ah, I know where you're going with this.
It's what I call a pressure test.
You're referring to negative building pressure.
Yes. Think about the physics here. Sucking all that air out of the building through 36 industrial dryers is exactly like trying to drink a really thick milkshake through a tiny plastic straw.
Oh, that's a great analogy.
Right. If you don't let air back into the cup, the vacuum pressure causes the cup to collapse in on itself.
It's a huge danger in commercial laundry design. When you have that many dryers violently exhausting air to the outside, you create a powerful vacuum inside that 3,800 square foot shell.
And what happens if the doors are closed?
Well, if the building is sealed up tight with the air conditioning running, the negative pressure becomes incredibly strong. A customer literally could not overcome the suction to pull the front glass doors open.
They would be trapped inside. Which sounds like a massive fire hazard, aside from just being a terrifying customer experience.
Oh, it's a severe life safety issue. But the vacuum effect causes another deadly problem, too.
What's that?
It starves the gas water heaters of oxygen. The negative pressure will literally reach up the exhaust flues of the water heaters and pull carbon monoxide back down into the building.
That is horrifying. How do you even fix that?
The Florida Building Code explicitly mandates a makeup air system, or MUA, to prevent it.
How does that actually work mechanically? Do you just open a giant window?
It's much more sophisticated than that.
Yep.
An MUA is a dedicated system with motorized louvers and massive fans. It pulls fresh air from outside and actively pumps it into the building to replace the air the dryers are ejecting.
So it's constantly feeding the building air.
Right. And it must be electrically interlocked to the dryers themselves.
Wait, interlocked?
Yeah. The moment the dryers fire up, the MUA system automatically snaps open and kicks on. It balances the atmospheric pressure of the entire facility in real time.
That sounds expensive.
It is expensive to install correctly, but it is an absolute non-negotiable operational necessity.
So basically, the inside of the building is a heavily engineered, controlled disaster zone.
Pretty much.
But looking at the sources, it seems like the local government is just as big of an obstacle as the physics of the building. Let's talk about the Florida and Polk County trapdoors.
Oh, yeah. Many first-time investors master the internal engineering, but get entirely blindsided by municipal regulations.
Let's start with impact fees.
In Polk County, water and sewer impact fees are assessed by a metric called Equivalent Residential Connections, or ERCs.
So they essentially measure how much strain your business puts on the city grid compared to a normal family home.
Precisely. The county calculates the daily water usage of a standard single-family home. Then, they look at your 22 industrial washers.
And figure out how many homes you equal.
Right, because laundromats use a staggering volume of water. This single 3,800 square foot building might be assessed as the equivalent of 20 or 30 homes.
Wow, 30 homes.
So for this Combi Road project, just the municipal fee for the right to connect to the county water and sewer grid can easily hit $10,000 to $30,000.
And that's before a single pipe is even laid.
Before a shovel hits the dirt.
I was looking at the Polk County Utilities Guidelines and the sources, and I was genuinely confused by this specific term. They call it an industrial user.
Yep.
Why is a neighborhood spot where people just fold T-shirts treated with the same regulatory scrutiny as a chemical refinery?
Because of the wastewater. To the county, you aren't just a retail shop. You are a high-volume wastewater producer.
Okay, that makes sense.
The Florida Plumbing Code actually mandates the installation of a commercial lint interceptor for these facilities.
I imagine this isn't just a little mesh screen over the drain.
No, not at all. It is often a massive underground concrete vault. Yeah. When hundreds of gallons of soapy, lint-filled water leave the machines, it doesn't go straight to the city sewer. It flows into this vault, which is full of a series of baffles.
Like walls inside the vault.
Exactly. These baffles force the water to slow down and change direction. This slowing effect allows heavy objects like coins or rogue plastic buttons to sink to the bottom.
Oh, I see.
And it also gives the hot water a chance to cool down before it hits the city's PVC pipes.
And if those buttons or heavy solids do make it into the city system, I'm guessing the county doesn't just send a polite warning letter.
They issue massive fines. In Polk County, depending on the final engineering review, the utility department might even require the installation of a 24-inch exterior sampling manhole.
A sampling manhole.
Yeah.
Yeah.
This is a dedicated, specialized access point located right outside the building. It exists purely so county environmental officials can show up unannounced.
Just surprise inspections.
Yep, they open the manhole and physically dip test your effluent water to check for prohibited solids, harmful chemicals, or extreme temperatures.
So if you fail to maintain your lint interceptor, they will definitely find out.
They absolutely will find out.
Man. Okay, moving from the underground manholes to the actual exterior of the building, we can't forget the weather. This project is in Lakeland, Florida.
And the Florida Weather Code is unforgiving. Remember the makeup air system and the exhaust ducts we just discussed?
Yeah, the giant fans.
Well, you have to cut up to 18 large holes in the exterior walls of this building to install the louver vents for that system.
That seems risky in hurricane territory.
It is. Every time you puncture the envelope of a building in Florida, you create a structural vulnerability.
Makes sense.
The code requires these installations to meet risk category 2 wind load requirements.
Which means what
It
exactly?
means that those louvers and their framing must be engineered to withstand up to 140-mile-per-hour hurricane force winds.
Unbelievable. And I assume the weather dictates the HVAC demands as well,
Yeah.
right? Because you aren't just cooling a room full of people reading magazines.
Oh, not even close. You are actively combating the immense latent heat and humidity generated by 36 drying pockets operating simultaneously.
In the middle of a sweltering Florida summer.
Exactly. If the mechanical engineer undersizes the air conditioning units, the store turns into a literal sauna. The customers will just walk out.
And your expensive computer payment systems.
They will overheat and shut down entirely.
Wow. I'm putting myself in the shoes of an investor looking at 610 Combi Road.
It's daunting.
You're facing simultaneous water discharge, negative building pressure, $30,000 impact fees, sampling manholes, and hurricane-force wind codes.
Mm.
How do you avoid buying a total money pit?
Well, the answer we found in the sources is a preliminary step called Phase 0 due diligence.
Phase 0.
Yes. Phase 0 is the dividing line between developers who succeed and developers who go bankrupt before opening day.
Give me some context on the cost.
A full Phase 1 architectural and MEP design package, where the engineers actually draft the blueprints you need to get your building permits, will cost an investor between $56,000 and $101,000 in design fees alone.
Just for the paper blueprints.
Exactly. You do not want to spend $100,000 on blueprints only to have the city tell you the building can't legally hold a laundromat.
Right.
So, before commissioning blueprints, you execute Phase 0, which typically costs between $4,000 and $8,500.
Okay, so it's essentially paying for a localized feasibility study. It's like paying a trusted mechanic a couple $100 for a multi-point inspection before you buy a used car.
That's a great way to put it.
But what exactly are you getting for that Phase 0 investment?
You get laser-measured, as-built drawings of the existing shell so your architects know the exact dimensions they're working with.
Okay, basic mapping.
You also get a comprehensive code study to verify if laundromats are even permitted by the zoning on that specific parcel. But the most critical component is the utility capacity check.
Because this is where you uncover the fatal flaws.
Exact.
So what does a fatal flaw look like on a utility capacity check?
Well, the engineer checks if the building currently has a 2-inch water meter available at the street. If it only has a 1-inch meter, you might have to pay the city tens of thousands of dollars to pair up the public road to install a new main line.
That would be a huge hit to the budget.
Massive. They also check the wastewater connection. Is the building connected to the city's sewer grid, or is it on a private septic tank?
Oh, if a building is on a septic tank, I imagine pumping a washing machine into it is a terrible idea.
It is a complete project killer. Laundry wastewater is classified as high strength. It is full of surfactants, soaps, and microscopic lint.
And the septic tank can't handle that.
No. If you pump hundreds of gallons of that into a standard septic drain field, the lint and soap bind together to form a biomat that completely seals the soil.
Meaning the water has nowhere to go.
Right. The drain field fails almost immediately. If a building is on septic, the local health department will force you to install an incredibly complex and costly pre-treatment system to clean the water before it even reaches the tank.
And Phase 0 uncovers that nightmare before you purchase the property.
Exactly.
There was also a structural check involved in Phase 0, right? Specifically looking at the concrete floor.
Yes, this goes back to the physics of the machines. The layout calls for 4 80-pound megaload industrial washers.
80 pounds of wet laundry spinning.
When an 80-pound washer goes into its high-speed extraction spin cycle, it generates terrifying G-force vibrations. A standard 4-inch commercial concrete floor slab will literally crack and shatter under that repetitive stress.
So what do you do?
During Phase 0, the structural engineer determines if you will be required to saw cut the existing floor, dig down, and pour a 6 to 8 inch thickened slab.
Laced with heavy rebar, I assume.
Yep, just to give those specific machines a safe pad to sit on.
Phase 0 is clearly a professional necessity. And the best part we found regarding the return on investment of Phase 0 is that the initial fee, that 4 to 8 grand, is very often credited toward your Phase 1 design fees if the project proves viable and moves forward.
It's true. It acts as a frictionless insurance policy.
Right. If the building fails the utility or structural checks, you walk away having only spent a few $1,000s dodging a massive bullet.
And if it passes, that money just rolls directly into your blueprint costs. It is the most effective risk mitigation tool a developer has when approaching a specialized commercial facility.
It's brilliant. So to bring this deep dive full circle for you,
Yeah.
transforming 610N Combi Road is so much more than slapping a fresh coat of paint on a retail box.
Vastly more.
Building a commercial laundromat in Florida is a masterclass in coordinating extreme mechanical loads. It requires managing the physics of simultaneous water discharge, balancing atmospheric building pressure so doors don't seal shut.
Engineering for hurricane winds.
Exactly. And navigating Polk County's incredibly strict environmental compliance laws.
And achieving all of that really requires a rigorous upfront commitment to due diligence. You have to ensure the physical bones and utility connections of the building can actually support the industrial heart beating inside it.
Absolutely. As we wrap up, we want to leave you with a final thought to ponder that builds on all of this intense infrastructure we've just unpacked.
It's an interesting shift in the industry.
It really is. We spent a lot of time talking about how complex the mechanical, electrical, and plumbing demands are right now. But as commercial laundry machines continue to evolve, achieving even higher G-forces to extract water faster, and utilizing high-efficiency technology to drastically slash their water and gas usage, how will the physical architecture of these buildings change in the future?
It's a great question.
Right. If tomorrow's neighborhood laundromats become decentralized, off-grid water recycling centers that clean and endlessly reuse their own water supply, how will municipalities like Polk County adapt their zoning code?
And those massive impact fees.
It's exactly. How will they handle facilities that suddenly produce virtually zero waste? It's a whole new frontier for urban utility planning. Thanks for joining us on the Deep Dive.